You will recall that compounds are formed when atoms of different elements combine. There are two kinds of compounds that can be formed: ionic compounds and covalent compounds. Ionic compounds are formed when a metal combines with a nonmetal or when a polyatomic ion is involved. Covalent compounds are formed when a nonmetal combines with another nonmetal. In ionic compounds, we have a combination of cations, or ions with a positive charge, and anions, or ions with a negative charge. We can use the ion charges to predict the formation of the compound. The charges have to balance so that the compound has a net charge of 0. Let's practice with some ionic compounds. Let's say we want to form a compound with Na, which has a +1 charge, and Cl, which has a -1 charge. We can write the Na ion as Na+, because it has a charge of +1. We can write the Cl ion as Cl-, because it has a charge of -1. Combining these two ions to form a compound, we see NaCl. Each Na has a charge of +1. Since there is only one Na in the compound, the overall positive charge in the compound is +1. Each Cl has a charge of -1. Since there is only one Cl in the compound, the overall negative charge in the compound is -1. +1 and -1 cancel out to be 0, so NaCl has an overall net charge of 0. Let's say we want to form a compound between Ca, which has a +2 charge, and Br, which has a -1 charge. Written as an ion, Ca is Ca2+. Written as an ion, Br is Br-. In order to balance the charges so that the compound has an overall net charge of 0, we get CaBr2. Each calcium ion has a charge of +2. Because there's only one calcium ion in the compound, the overall positive charge of the compound is +2. Each bromine ion has a negative charge of 1. Because there are two bromine ions in the compound, we have an overall negative charge of the compound of -2. +2 and -2 cancel out to have a net charge of 0. Let's say we want to form a compound with Al3+ and O2-. We see that the resulting compound is Al2O3. Each aluminum ion has a charge of +3. Because there are two aluminum ions in the compound, we have an overall positive charge of +6. Each oxygen ion has a charge of -2. Because there are three of them, we have an overall negative charge of -6. +6 and -6 balance out to be 0. Let's look at a helpful hint when we're writing ionic compounds. All we need to do is switch the charges and make them the subscripts. So the anion charge becomes the subscript for the cation, and the cation charge becomes the subscript for the anion. Let's look at the examples that we saw previously. Na+ and Cl-. The anion charge, -1, becomes the subscript for the cation, which is Na, so we know we're going to have one Na, and the cation charge, +1, becomes the subscript for the anion, which is Cl, so we know we're going to have one Cl. Anion charge becomes subscript for the cation, and cation charge becomes subscript for the anion. We can see that the anion charge, -1, becomes the subscript for the cation, 1, and the cation charge, +2, becomes the subscript for the anion, 2. We see that the anion charge, -2, becomes the subscript for the cation, 2, And the cation charge, plus 3, becomes the subscript for the anion, 3. Let's do some guided practice. We need to switch the charges and make them the subscripts. Let's check the charges to make sure that they balance to be 0. Each lithium has a charge of plus 1. Because there are 2 lithiums in the compound, we have an overall positive charge of plus 2. Each oxygen has a charge of minus 2. Because there's only 1, we have an overall negative charge of minus 2. Plus 2 and minus 2 balance out to be 0. We need to switch the charges and make them the subscripts. Each Mg has a charge of plus 2. Because there are 3, the overall positive charge is plus 6. Each N has a charge of minus 3. Because there are 2, the overall negative charge is minus 6. Plus 6 and minus 6 balance out to be 0. We need to switch the charges and make them the subscripts. We come up with this, but we see that it can be simplified by dividing both subscripts by 2. This, as it is listed here, Ca2O2, is not correct. We must reduce it to the simplest form to get CaO. Let's check the charges. Each Ca has a charge of plus 2. Because there is only 1, we have an overall positive charge of plus 2. Each O has a charge of minus 2. Because there's only 1, we have an overall charge of minus 2 in the compound. Plus 2 and minus 2 balance out to be 0. Let's practice with some polyatomic ions. The idea is the same. We need to switch the charges and make them the subscripts. But we must remember that the polyatomic ions must stay together as a group. So the anion charge, which is minus 1, because NO3 is the anion, becomes the subscript for the Na. The cation charge, which is plus 1, becomes the subscript for the anion, which is NO3. We need to switch the charges and make them the subscripts. We see here that the NH4 occurs in parentheses. This is because the NH4 must stay together because it is a polyatomic ion. However, we must have 2 of them because the charge on the anion is minus 2. We need to switch the charges and make them the subscripts. So we should have 2 aluminums and 3 CO3s. Let's try some practice on your own. We need to switch the charges and make them the subscripts. We see that each K has a charge of plus 1. Because there are 3, we have an overall positive charge of plus 3. Each PO4 polyatomic ion has a charge of minus 3. We have only one of these polyatomic ions in the compound, so we have an overall negative charge of minus 3. Plus 3 and minus 3 balance out to be 0. We need to switch the charges and make them the subscripts. Each SR has a charge of plus 2. Because there's only one SR in the compound, the overall positive charge is plus 2. Each OH has a charge of negative 1. Because there are 2 OHs in the compound, we have an overall negative charge of minus 2. Plus 2 and minus 2 balance out to be 0. We need to switch the charges and make them the subscripts. Each Ca has a positive charge of plus 2. Because there is only one, we have an overall positive charge of plus 2. Each CH3COO has a charge of -1. Because there are two, we have an overall negative charge of -2. +2 and -2 balance out to be 0. When we talk about covalent compounds, it's very easy because there is no way to predict the formation of covalent compounds based on charges. We can look at a compound and tell that it is covalent simply by noticing that it is composed of two elements that are nonmetals. Other than that, we have no way of predicting the formation of covalent compounds.